Okay, happy COVID lab day. So what we're gonna do is I'm gonna demonstrate two types of cars. One is called the constant velocity car. And a constant velocity car is just that. It goes at a constant velocity. I didn't get it quite on the track. I'll do it better next time. A constant velocity, which means it doesn't change its velocity except at the very beginning it changes really quickly. This is a fan cart. And the fan cart goes slow and it picks up speed faster and faster. And so the fan cart is an example of a type of acceleration. And so I'm going to put it on this graph. I'll zoom in the graph in a moment. So this first one, I'm going to put it here nice and straight. And I'm going to start the graph and you'll see it's going to record. So you see this thing's recording. Click, 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 click. It's recording. So I'm going to stop that. And I'm going to delete that. And I'm going to put this one on and we're going to go for it. Okay, so this is we're going to record data for this. Ready, set, go. Okay, that's the first one. And that gives me a certain data up here. I'm going to do the exact same thing here, but I'm going to do it this time for the fan cart. Turn it on and push record, and it's going to speed up, and there it goes. Okay, so what's the difference? So today, the biggest thing is finding the difference between the two types of stuff. Two types of graphs. And so right now you can't tell the difference. I'm going to change this one. This is a run one. Run one, if you remember, was the car. So I'm going to put car there. And then run two, I'm going to change that, rename that to fan cart. And okay, so we got the car and the fan cart. So this is what's called the position versus time graph. And I'll put the car on the left. So it says car now. And I'll put the fan cart on the right. It already said fan cart. So I got the car versus the fan cart. And hopefully you can see the difference right there. That's pretty big. The car was going at constant velocity, so it's a straight line. And the fan cart is going at an accelerating rate. And so it's actually an upward curve. Yay, so far so good. So what is that going to look like on the next page when we look at a velocity time graph? So let's do the same thing, a VT graph. So I'm going to put the car on the top here, and I'm going to put the fan cart over here on the right, and so far this is the same thing we had last time. I'm going to add a velocity time graph here on the bottom. It's the same thing. Move the camera. I got to watch the camera and do this at the same time. So the car will be here, and the fan cart will be here. And what I'm going to look at on this one, I'm going to get rid of that. What I'm going to look at here is I want to look at the middle part, because that middle part is a good example of it. And it's where the car is going pretty much the same, a constant velocity, right in the middle. See how straight that is, like an arrow? And so this is also flat. Now it's actually not going to be entirely flat, and the reason it's not entirely flat is actually because this area here is off the table a little bit because of the sensor. And then it goes flat here. So if you notice, even if no battery, no power, the cart actually rolls that way. So it's getting a little bit of gravity assist. It's a little bit downhill, which actually makes my data here a little bit off. So it's actually, my velocity is increasing a tiny bit. And that's because it's increasing because of gravity. Anyways, this, when it's constant velocity, this should be nice and straight, which it really does look pure that way. And this should also be flat. Flat means my velocity is not changing. Here, this is actually a slope. And that makes sense. It's an upward slope because my velocity is increasing at a constant rate. That fan is super constant. So I have a nice constant acceleration. Okay, in the last one, we put them three together now. And so the third one is going to I'm going to do the exact same thing before. I'm going to go, this one is my position time graph. And one for the fan cart and one for the car. And the middle one is my velocity time graph. On the left, I'll have the car. And on the right, I'll have the fan cart. And then in the bottom one is my acceleration time graph. And so there's that. And there's that. So, wow, that's kind of ugly looking. Let's go to the better data on the next page. Okay. So this data I was able to take, after trying, and it's actually really good data. The other data, that's just one shot. Sometimes you don't get it in one shot. So what we have here is we have a nice straight constant velocity and a little bit of junk at the end where it hits some bumps. And then here's my nice straight constant velocity here. And since it has constant velocity, it has zero acceleration. So that makes sense, zero acceleration. So On a xt graph, you have a slope, and the faster you go, the steeper it is. But since there's no curve here, then that means my velocity is the same the whole way, and I have no acceleration. So that is my car. It is the car. It is the constant velocity car, and that is on the left. Okay, and then on the right, we're going to do the fan cart, and the fan cart had a curve, and the curve on an xt graph means, hey, you are speeding up. Well, that's great, because this velocity was not speeding up. This velocity is obviously increasing. So this middle one is a velocity time graph, and it is increasing. It's getting faster, and that's why this is an upward curve. And so what does acceleration say? Well, the acceleration here was 0. Acceleration here was 0 because I had no change in velocity in a straight line. And then over here, I have acceleration, but this is a straight line, so it means that's constant acceleration. And this is a relatively constant line. And so down here, I have some notes, and I will go over these notes, and I will have you write these notes along with me so that they make sense as we create them. So I will see you in class mañana.